All right, guys, we talked about compound transformation today. You had this photable. Just make sure you have your information. I stamped this. I think you're pretty good, but in case you are absent, I'll have a blank copy of the photable in the notes folder on Edmodo, and you can get in the information. So we know that a compound transformation is when two or more transformations occur combined together. And we talked about being able to identify the types of transformations that are occurring through the image, looking at between the pre-image to the image and to the image double prime. So we pretty much, one thing I stamped to check, remember you had to kind of fill in your tables, your coordinates based on the compound transformation. And basically what occurred in part B was a translation. You can see that it physically slide. So we did the 90-degree rotation first from the image ABC, and then A prime, A prime, B prime, C prime. So you should have this information here. And then there was one you had to do on your own. And let me go back. I think it's down here. Check your understanding. Yeah, just make sure you have your order pair correct. And I could see that based on your picture. So the graph is to help you. If you know the rule, you can just apply it and fill in the coordinates. So this was the first example that I needed you to do. You will, and I'm going to hopefully see this on the post, you have, basically you're going to have a homework quiz based on your IMB practice 2 and the examples that you should have in your spiral notebook. And then we're going to check for understanding what's the new problem. So make sure you have this done. I'm going to go through this real quickly. You can pause, rewind if you need to. But basically, there's two transformations that we have here. The first thing is they want to translate 0, 4. Understand that this is written in component form. So this form 0, 4 is the same thing as saying x plus 0, which would just be x, and then y plus 4. And so what we're going to do is we're going to start with our image, our original points. And I'm going to go ahead and just get them graphed. So we're going to show it, and we're going to do the steps, get the coordinates, and then graph it so we can see how the composite transformation looked. So we had a 6, I probably should do this, but we had a 6, -1, and then 10, -2, and we had 5, -3. And we're going to connect those. I didn't go to -2. Let me fix, oops. I need to fix my negative. Delete. Delete. It's 10 -2s here. All right. We have J, we have K, we have L. All right. All right, so the first thing they want us to do is we're going to translate using the component form 0, 4. So all I'm going to do here is basically take my coordinate of J and get the J prime. I'm going to take the order pair that we had, 6. That's going to say like plus 0, just say 6. And then we got -1 plus 4. I'm just going to apply the rule to each coordinate. And so J prime really is 6, 3. And then we're going to do this, let me scroll up just a little bit, for each point. So if you want to kind of just show the mapping or show the application of the rule, this is going to be 10, and then -2 plus 4, and then we're going to simplify that and get 10, 2 for K prime. And then we'll do the same thing for L prime, so that stays the same, 5, and then a -3 plus 4. So we get 5, 1. All right, and then we're going to graph that that transformation, that translation. So we're going to put our JKL prime 6, 3. I'll put this one in black. Okay, so J prime 10, 2, and then 5, 1. So basically we see that this original image was just a slide up 4 units. All right, and then for the second part, they want us to reflect it over the y-axis. Okay, so reflection is the key word over the y-axis. There's a rule that we can that whenever we're dealing with the reflection to negative x comma y. So basically the x is changing, the y is staying. And we're going to do that to our prime coordinate. So j double prime, I'm going to use the rule to my j prime. So I'm going to now change this, well, so you understand what points are going to go. It's going to be negative 6 comma 3 because the x coordinates are going to change for all of our image points. So negative 10 comma 2 and L, and it should be double prime, sorry about that, negative 5 comma 1. And then we're going to graph these points. That's j double prime, negative 10, 2, k double prime, and negative 5, 1. Double prime. And connect those so that we see that this, we started off with 1, then it went to 2, then it went to 3, and 3 and 2 are reflections of each other, 1 and 2 are translations from each other. And so basically what I'm going to check, I will give you a similar problem, ask you to follow these steps with the new rule and with the new reflection. And you have to give us our final order pair. I am really going to focus that you can at least get to the double image, double prime image, the ending point. And so the next example you have was here. We had the points A, B, C, and they're going to be reflected over the y-axis, and then translated a negative 2, 3 using the translation rule. So start off, let's get our points down. We have 3, 1. So if you want to pause, let me just get this situated. Get yours down, I'll get mine down. All right, this is going to be our step 1. We're going to reflect over the y equals x. Now, whenever we reflect over y equals x, it has its rule of its own as well. Basically, the order pairs get switched. So instead of having xy, oops, this is going to happen again. Sorry about that. Instead of having xy, it's really going to become y comma x. Okay, so all I really need to do that is come up with the new order pair, or switch to order pair for each coordinate. So A prime is going to be 1, 3, B prime, negative 3, 0, and C prime, negative 3, comma 3. So we're going to go ahead and graph those points. A prime, negative 3, 0, negative 3, negative 3. Where did I mess up? Oh, it was a positive 3. Man, I did it again. Sorry about that. There we go. Because this needs to be a reflection. Yeah, duh. All right, so because this line is a diagonal line, so with the slope of 1. So it's just a direct variation. Going through, the slope goes to the origin. So we should see a reflection amongst that point. And then step 2 tells us that we're going to translate it with the vector component form of negative 2, 3. So Second thing we're going to do is translate. And this basically means we're going to subtract 2 from x, add 3 to y. We're going to do that to every point. So a double prime here is I'm going to subtract 2 from 1, that gives me a negative 1, and then add 3 to 3, get 6. I'm going to continue this rule for every point. This would end up being negative 5, 3, and then c double prime would end up being negative 5, comma 6. And then we're going to graph those points to show the composite transformation. So go ahead and get those graphed as well. And then we're going to talk about what happens when you do a composite transformation or a reflection over parallel lines compared to intersecting lines. So that's the third example is where we're looking at when the lines intersect. This is a very important property that occurs with composition transformations. So if we reflect an image over 2 lines that are intersecting, it pretty much creates one transformation and just going from our image to our pre-image to our image. So let's get the 2 points on the graph to start us off. So we have a negative 7. I can move this. Oh, I can. Sorry. We're going to connect that segment CD. Now, they want us to reflect this image over the x-axis. First thing we're going to do is reflect it over the x-axis. Well, the rule for reflecting over the x is the x stays, the y changes. So basically our c prime is just going to be negative 7, negative 1, and our d prime is going to be negative 3, negative 2. And we're going to graph that over the x-axis. So if it's in the quadrant 2, it should end up in quadrant 3. And we should see that it's equal distance from our line of reflection, because our line of reflection at first is x. And I see c is 1 unit from x, so c prime is going to be 1 unit for x. d is 2 units from x. d prime is going to also be 2 units from x, from our line of reflection. So then we show that. All right, then we're going to rotate it amongst this image 90 degrees amongst the origin. So this is our second thing we're going to do here. And a rotation 90 degrees, positive degrees is counterclockwise, will give us negative y comma x. And we're going to do that for our image c prime and d prime. And let's get that graphed. This was c prime, double prime, excuse me, and then 2, negative 3. I graphed that wrong again. 1, negative 7. All right, so make sure we have that image and we see that if we have a reflection in intersecting lines, okay, the point of intersection would be our basically our dilation, our point of rotation. And if I was to measure the angle, and I'll have to do this on the geometry sketchpad, you would see that the degrees would be double from that. But since these two lines basically intersect here, we are going to have a rotation, which is what they're trying to show you amongst the two. So get that one done, and I asked you to add that. Was there? I thought there was one more. I missed that one. Yep. Okay. So yeah, there we go. The last thing, I will be posting a partial key. Just give me a second here, and I'll get that done. But we should have our. This is where I'm going to be pulling your quiz questions from, your homework check questions. You'll be very much familiar, you know, on IMB, what was the answer to number 9? And then I'll give you one similar to it. So if you have any questions, check the hints that I'm going to post on Emoto and post the question or come to me in the morning because we will be checking this and checking your understanding. And these are some similar test-like questions that you need to make sure you are familiar with. All right, thanks, guys.